Hello everybody. In this video we'll be going over one of the sections in chapter 6 of our text entitled Chemical Composition. In this video we're going to figure out how we go from and get molecular formulas from empirical formulas. Now we saw how to do the reverse of this before. Given our molecular formula, we can figure out the empirical formula pretty easily. Going from the empirical formula to molecular formula, though, is a little trickier. We need a little extra bit of information. And I think the easiest way to think about why that's true is by thinking about a series that we're going to go through. So let's take a look at these different sugars that we have here. And think about their molecular formulas and their empirical formulas. They all have the exact same empirical formula. But each of their molecular formulas is some different multiple of this, right? So this would be 4 times the molecular formula. This one would be 3 times the empirical formula. This one would be 5 times. This one would be 6. So the extra bit of information that we're going to need is the molar mass of the molecular formula of these different sugars. So the molar mass of glyceraldehyde, for instance, would be 90. The molar mass of erythrose would be 120. And you can see that these are all going up in even increments. Now, if we calculated the molar mass of CH2O, we see that that is 30 grams per mole. So 3 times that is 90, 4 times that is 120, 5 times that is 150, and 6 times that is 180. So it's pretty clear, if you think about it, that if you took that 30 and you took the molar mass of 90 divided by 30, you get 3. And that's the factor that we need to multiply by here to get these subscripts. Multiply these subscripts by to get the correct subscripts for the molecular formula. Similarly, if we took 180 and divided it by that 30 grams per mole, we'd get 6, which is what we need to multiply these subscripts by to get our molecular formula here. So now that we've thought about that, let's do a little recap. The molecular formula is a multiple of the empirical formula. And to determine the molecular formula, you need to know the empirical formula and the molar mass of the compound. What our formula is going to be is that we take the molar mass of the actual real molecular formula and we divide it by the molar mass of the empirical formula. This is the factor we're going to need to multiply all of the subscripts of the empirical formula by. So we want to determine the molecular formula of catenine if it has a molar mass of 204 grams per mole and an empirical formula of C5H8. So the first thing we need to do is determine the empirical formula. And we might need to figure it out before. So we could have backed this problem up and just given us percent composition data. But in this one, we're just given the empirical formula directly. At the end of this, we'll do one where we actually combine these two together, and you can see the whole problem put together. The next thing we need to do is determine the molar mass of the empirical formula. So we have 5 carbons and 8 hydrogens. So altogether, we're going to get a molar mass of 68.11 grams per mole. The next thing we need to do is follow our formula. So we'll divide the given molar mass of the compound, this 204 grams per mole, by the molar mass of the empirical formula that we just calculated. When we do that, it's not going to work out perfectly to 3, but it's really close. And so we'll take this as the factor that we need to multiply by. So next we'll multiply the empirical formula by the factor that we just calculated in order to get our molecular formula. So we take C5H8 from here, multiply it by the 3 we just calculated, and we get C15H24. So let's try one more example. Benzoprine has a molar mass of 252 grams per mole and an empirical formula of C5H3. What is its molecular formula? And we've been given here the molar masses of carbon and hydrogen in the empirical formula that we're going to use. So the first thing we need to do is calculate the molar mass of the empirical formula C5H3. We have 5 carbons and 3 hydrogen. When we do that addition, we see that we get 63.08 grams per mole. The next step is to figure out the factor we need to multiply by. We take the given molar mass of the molecular formula for benzoprine, and we divide it by the molar mass of the empirical formula. And we get about 4. We can then multiply our factor by each of the subscripts of the empirical formula, and we get the molecular formula for benzoprine, C20H12. So let's try a challenge problem where we bring together everything that we've been talking about over the last couple sections. We're going to be asked to determine the molecular formula of nicotine, which has a molar mass of 162 grams per mole and is 74% carbon, 8.7% hydrogen, and the rest nitrogen. We're given some molar masses to use for each of carbon, hydrogen, and nitrogen. So we need to be recognizing a couple of things here. We're being asked for the molecular formula, we're being given a molar mass, and we're being given the percent composition in this case. So if we start to look at examine what we're given, we know that there's 74% carbon and 8.7% hydrogen, but it only says the rest nitrogen. We need to recognize that it needs to add to 100%, and then if we subtract out the percentage of carbon and the percentage of hydrogen, we'll arrive at the percentage of nitrogen, 17.3% nitrogen. And I hope that at this point we can recognize that what these percentages mean is that if we had 100 grams of nicotine, there would be 74 grams of carbon, 8.7 grams of hydrogen, and 17.3 grams of nitrogen. Again, it's always useful to think about what the formula is going to look like. So we have carbon, hydrogen, and nitrogen, and they need some subscripts. We'll gather together our conversion factors because we know that we're always going to have to go from these masses over to moles. So we have 1 mole of carbon for every 12.01 grams. 1 mole of hydrogen is 1.1 grams, and 1 mole of nitrogen is 14.1 grams. We were given these initially in the problem, but we could have looked them up in the periodic table. Our solution map from here is that we've already got all our masses. We need to find the moles of each one of the components, write our pseudo formula, and then adjust those subscripts until we find the empirical formula. So if we divide each one of the masses by the molar mass that we have, we can get the moles of each one of our components. We'll use those moles as a subscript for a pseudo formula. Again, now we'll divide by the smallest one. Luckily, this time, everything worked out to some whole numbers. But it's very important that we recognize here that this is the empirical formula, and we're being asked for the molecular formula. So we still have some work to do. We need to calculate the molar mass of this empirical formula that we just figured out. Once we do that, we'll see that it has a molar mass of 81.13 grams per mole. A little sanity check here. That's less than the molar mass of nicotine, so we're on the right track here. We need to figure out what is the factor we need to multiply by these subscripts in order to get to the molecular formula. So we take the molar mass of nicotine, and we divide it by the formula mass of our empirical formula, and we get our factor of 2. Now we can multiply each of the subscripts in our empirical formula by 2, and we get our final molecular formula, C10, H14, N2. You can see that these problems can get pretty difficult with a lot of different steps when asked in the right way. But it's important to realize that really you're just building up all the other little problems that we've been doing all along.